Hello and welcome to this video on how we can make a Python GUI to interface with our Arduino. Note that there are two on and off buttons controlling the built-in LEDs on the Arduino board on the right. We can turn this LED on and off. And in this video you'll learn how we can program this and how all the pieces of software interact and work together. Here's a block diagram that helps us understand the data path and how the pieces of code will interact with each other. At the bottom left, we have our user command, which is the user pressing the button. These buttons are located in the Python GUI, which is the gold box at the top left. These contain the blink buttons, and we make the buttons using Tkinter, the built-in Python module. The way that we get the button state, whether it's on or off, is to use PySerial, which transfers that button state to the Arduino. PySerial uses a serial communication protocol, and this is a third-party module that you'll need to download in order to have that module supported. So go ahead and get that if you don't have so already. The main function of the Arduino code, the block at the top right, is to wait for those blink commands. Once the Arduino receives the blink commands, it then lights the LED on or off. So it will provide a low or a high signal value to that LED, which will turn it on or off. We'll start by looking at the Arduino code, and I'll assume you have some familiarity with programming the Arduino. Remember, the main goal of this code is to wait for the user's input. First, we create the variable, a character that is the user input. So this will be the value that determines if they select on or off. In the void setup, we initialize the Arduino. We first set the baud rate. So this will be for supporting the serial communication. We do serial.begin 9600. And that's an important value to note because we'll need to match that on the Python side. Next, we initialize the built-in LED. So we do pin mode, LED built-in, and then we set that pin to an output. In the void loop, or the program that's continuously running, this is where we're waiting for a serial input. So in this loop, there's an if statement. So if serial available is greater than 0, then we execute the code, which means then we got a user input, and then we read that input, which is the first line of that if statement, user input equals serial.read. In this case, if the user input equals a lowercase o, then we turn on the LED. We do a digital write to the built-in LED and we set it to high or on. If the user input equals a lowercase x, then we turn the LED off, or we write the built-in LED low. So this code is simple, and remember, it's simply waiting for the user's input, it checks that input, and if it's a valid entry, then it does something. In this case, it turns on the LED or turns off the LED that's built into the Arduino. Now let's look at the star of the show, the Python code, which will have the two buttons that control the on and off, and will be the GUI responsible for the communication between our mouse click and the Arduino LED blinking. Up top, lines 1 through 3 are the imports that we'll be using. The first is importing the PySerial module. Remember, this is a third-party module, so you'll need to go ahead and download that. We do that by import serial. Lines 2 and 3 are the Tkinter imports. Line 3 is pretty standard, import Tkinter as TK. Most folks do it that way. You'll see reference code like that. I recommend doing that. Lines 5 and 6 are the initialization lines of code for the serial communication. I went ahead and made comport a variable. So I'm using a Mac, and this is the comport style it looks for. On Windows, you'll see like com3 or com2, something like that. So you need to go ahead and figure out that one. Line 6 is ser equals serial.serial. And the first parameter is the comport, which is a variable defined above in line 5. The next parameter is the baud rate, which is the one we wanted to note from the Arduino code. So these two need to match, or else there'll be timing issues. And then finally, timeout. So this is a value that's in seconds, And what it's meaning is that if the serial initialization doesn't take place within 1 second, we get a timeout. Next, we move on to the turn on and turn off LED functions. As the names of these functions suggest, the first one on line 8, turn on LED, turns the LED on. So remember that the Arduino code is simply waiting for a serial input, and it's waiting for a particular input to turn on the LED, which is the lowercase o. The way that we do this using PySerial is to do ser.write, and we prefix the lowercase o with a b, signifying that it's a byte of data. It takes care of the formatting and makes sure that we're transmitting a single character, which is what we want to do and what the Arduino is actually looking for. Below these two functions is the Tkinter code, which will be the code that's responsible for the GUI and the one that maps the functions we created to the buttons. Line 15, root equals tk, is the line of code that initializes our window. This window is where we're going to be placing our widgets, which is the term used for objects within the window. In this case, we're going to be placing buttons, but you can also do entry boxes, among other items. This line of code is standard across many programs, and I suggest you use the same terminology. The next line of code, root.title, and then in parentheses the string blink GUI, title is the window. This is our first customization of our GUI, and this will be the text that displays on the top of the window. Lines 18 through 22 is where we're defining and placing our button. It's important to note that in Tkinter programming, you have to create your widget, in this case a button, and then you need to place it within the window. So it's a two-step process. We'll start with the on button. Button on equals tk.button, and then we have 3 parameters. The first, root, what this does is places the widget within the window. So we're telling it where to go. In this case, it's root. Text is going to be the display text on that button. And of course, you want to make this make sense to the user. So turn on is pretty straightforward. We're turning on the LED. The third parameter, command, is the way that we're binding the function to the button. Notice that when we call this function, we don't have input parameters, and the parentheses are omitted for the command equals. This is because if we use command in this way, we can't pass input parameters. And we can work around this, but that will not be the topic of this video. So for now, understand that using it this way, you can't pass data to your function that you're calling. So to summarize line 18, we're creating an on button, and we're defining its characteristics. Line 19 is where we're placing the widget within the window. There are 2 main ways to place a widget within the window. You can use grid and you can use pack. I like to use grid here because it's more intuitive of where the placement of the widgets are going to be. We define the row in the column. You'll see there we have button on dot grid, the row and the column. Just like a table, it becomes obvious the row and the column. And there's definitely shortfalls to this depending on what your widgets are. However, pack, if we were to use that, is more relative. So you say pack equals top or side, left or right. One thing to note when getting started with Tkinter is you can't always mix grid and pack together. You can have grid and pack within one Tkinter program, however you have to take some care to do that, and that will be out of the scope of this video. So for now, just know that if you define the root in the windows like we have today, you can't mix grid and pack. And again, in future videos, I'll address how you can use grid and pack within one program. Moving to lines 21 and 22, it's basically a copy and paste of the button on, but we replace button on with button off. So the middle parameter there is different. Instead of turn on, it's turn off. And the command that we call is turn off LED as opposed to turn on. Again, a key concept to understand is that we create a widget, which is in line 21, and then we place the widget within line 22. Line 21, where we define the widget, we define its characteristics. and then 22 controls the placement of that widget within the window. In line 22, notice that we put column, and I added, instead of 0 as in button on, it's 1. So in this case, the on button and off button will share the same row, but then the column will be different. And if you accidentally don't update column 1 and you left it 0, then the off button would simply override the on button and you wouldn't see the on button. So remember to update the column. Moving on to the last two lines of code, we have 24 and 25. 24, root.geometry defines the window size. Here, this is a little bigger than we need. I did 350 by 350, but it's just to demonstrate that you can control and fix the window size, as opposed to being the default, which will basically hug the outside of the buttons. So this is just to note and to tell you you can control the size of the window. The last line of code, root.mainLoop, makes sure your GUI continuously runs. Thank you for watching this video, and I hope you learned about how we can create a Tkinter GUI and control our Arduino. Stay tuned for more content on how we can update these programs, add more functionality, and learn more about how we can use Tkinter to create more customization and useful functions. Thanks again, and let me know what you think in the comment section. The code for this video will be posted on GitHub, so find that in the description.